Okay.
This is like the only
What other classes do you teach in the fall? Right?
Yeah, yeah. In the fall, I'm doing a 160, a 180. So statistics, calculus, and then a 298 course, like a 108 course, which is like 90 and 110 put together.
oh, no worries. What do you want to say?
Oh. I'll give you guys the synthetic vision handout.
I know you think it's good when the AC turned on, you look like this down.
Alright, print shop is way on the other side of campus.
Let's write into number.
Okay, yeah, so different reasons.
Yeah.
Didn't forget about you guys.
Oh, this looks complicated. Oh, okay, this is, okay. I thought it was like actual worksheet. I was like, what is this? What is this?
It's just a helpful tool.
It's a little guideline.
I was about to say, I was like, there's no way we're about to do this right now. I just
Ain't
got
no
a
way
break.
in hell I'm gonna be doing this. Okay. He goes back to class, sees the work he has to do. Nope.
He's cool, man. Don't worry. He's good.
You ever heard of Jeff Dunham?
Yeah. What?
Your name reminded me of him.
Oh, yeah. All right. Little peanut. Right? Got a little too political in the wrong direction for me. That's all right. All right. So I just gave everybody got the synthetic division. That's really just for you. I've got a couple examples. You got the long division problem, and then an example of synthetic, and then I redo the long division problem at the bottom. Cool. So that's just a reference for you. Okay. All right. So, do you guys want to do any more from 7.3? I think we pretty much covered everything you could see from 7.3. I want to devote most of the remaining time to 7.4 about the unlike denominators. Let me show you something that very often students aren't shown for some reason. If I had to add these two things together, let me see.
This is from 7.3?
7.4. What you got, Jeff? I don't know, Jeff. Let's do
20? On the bottom?
Oh yeah, I like this. All right.
Oh, 14.
Yummy. 42 is the answer. That's kind of gross. Do you agree? Especially with the methods you're normally shown. The whole idea of getting an LCD is work with what they already have, give them what they're missing relative to the other dude, and then they're both the same. So what do I mean by that? So an easier problem would be like, what do you got, Jeff? 1/9 plus 2. What do you got, Jeff? Let's do 5/27, right? So what's he missing that he's got? A factor of?
3?
Oh, we're better than that. 3. They're only missing each other if they don't already share something. Don't they both share a 9? In fact, that leads to a better way to do it in general. If I identify what they already have in common and break them down that way, I can see what they're each missing. So can somebody figure out what's the largest number that goes into both of these? You can do it. 6. 60 is 6 times 10. 42 is 6 times 7. Do you see how it's really easy? And I kind of compare this to having kids. If you give this one more sprinkles than this one, you got some sprinkles. And then I eat them both just to make it all quick. Can you see? They both already have ice cream. They both already have a 6, right? But what's he missing that he's got? A what? What's he got that he's missing? 7. Right? Can you just see it? And what's he missing that he's got? 10. So you give each of them what they're missing relative to the other one, and they end up with the same thing, which is the whole point of LCD, is to make the bottoms the same. So if you give this guy a 10, and you give this guy a 7, don't they both have 6 times 10 times 7? Bless you. Right? I didn't do this on purpose, but what's 6 times 10 times 7?
No idea.
20. So you get, what do you get here? You get 49 over 420 plus 110 over 420. Do you guys, have you seen that method before?
Yes.
No.
A few of you guys? Some of you guys have never. If you've never seen it, does it make sense? It so desperately makes sense because this is exactly what LCD is trying to accomplish. You've got all these other ways. You can list all the factors of 60 until you go insane to get what 42 also goes into. So I love to teach this to my Math 88 students, not only because it makes this kind of problem easier, but because it's the only way you can do it when you have variable stuff on the bottoms. You have to do it this way. So, and then of course you just add this shit together, you get 159 over 420. I don't think that reduces. Plus you. It might. Actually it does. How do I know that a 3 goes into this?
9.
1 plus 5 plus 9 is 15, which is a multiple of 3. 3 goes into 420 because 6 goes into 420.
140.
So you can divide both by 3, so it'll be 53 over...
140.
Who is it?
140?
140 is. You said it like that.
140.
All right, cool. I like it. You guys, the last step I don't care about, but this step, making the bottoms the same, is just so damn easy if you figure out what they have in common already. And then you can focus on what they don't have in common. So how does this work when I have variable expressions? It works the same way. Shoot. Okay. So if I have, like, let's say, 11 over x squared minus 9 plus 2 over x squared minus 5x minus 24. So what was my first step here? Factor the bottoms, right? Now in this case they're numbers. I can figure out what's the most they have in common. Over there's really just one way to factor them, so I don't have to worry about that 6th step, that what do they have in common. I just factor them because it's the one way I can. And then I'm going to see what they have in common, what parts they already have in common. So how do I factor this dude? Yeah, x plus 3, x minus 3. By the way, this is just more evidence of the thing I said earlier. If you're not good with factoring, Chapter 7 is shut down for you. You can't do it. Right? And then this guy.
X minus 8.
Good.
X plus 3.
Is that cool? I'm just crossing it through because I'm rewriting it. Is that cool?
Yeah, that's nice.
So now you can, what do they have in common? What do they both have?
X plus 3.
X plus 3. So the other stuff is what they each are missing.
Yes.
So what do you multiply this first dude by? What's he missing?
X minus 8.
X minus 8. Of course, this guy is missing
X minus 3.
x minus 3. That's the only thing he's missing. Now are the bottoms the same? Gracias. So yes, the bottoms are the same. They both have this, this, this. They both have this, this, and this. They both have the same stuff. Let me stop there for a second.
What is the direction that's going to be given? On the side?
Simplify.
Okay.
Simplify always means carry out the operations. If you see addition, do it. If you see multiplication, do it. Factoring means the opposite of that. Factoring means what? Undo multiplication. So sometimes when I say simplify, people factor, and I'm like, no, you've just completely done the opposite of what I asked. All right, how do I proceed? What do you get up here?
11x minus 88.
Now notice this is a plus. If this was a minus, you'd have to be careful about it. And the way I would do it, if that was a minus, I would make this a plus and put the negative there. So when I distribute, I'm distributing a -2. I don't forget to distribute the negative through. Right? Right now it's just a plus, who cares? So over here I get 2x minus 6. All over x minus 8, x plus 3, x minus 3. Let's go further. Yes. Ooh, now you're really dangerous. I love it. All right, and then of course, this feels a lot like the last stuff we were doing. We're at the cleanup step. I get 13x
minus 95.
all over x minus 8. For some reason, when people do this, they just kill the bottom. The bottom just goes away. I'm like, that's some magic shit. Yes?
You kill the bottom when you have an
Equation.
Equation, okay.
Because then you're allowed to multiply both sides by that bottom.
Yeah.
Here, this is not an equation. How in the world am I allowed to multiply anything? There's no other side to balance it out. Yes?
So, so on that one part where it's like x minus 8, x plus 3, and x minus 3, and the other one also has the x plus 3, do they kill each other, the x plus 3 and x plus 3? And
What's the only way that they would be able to kill each other? Is if one was on the top and the other was on the... Why does that cancel? Because one is multiplying, the other one's dividing. So they have opposite operations. Here, they are both on the bottom. There's no way they're going to kill each other.
Okay.
Yes?
And because it was the addition, we're not doing distributing.
Oh, yeah, I still distributed the 2.
No, because the whole problem itself is addition, I don't have to do that negative distribution.
Yeah, exactly. I mean, if this would have been a minus, then you would have had to distribute that through. Yes. We'll do one like that now. Yes?
How come we didn't, maybe I missed this, how come we didn't, like, keep the x, minus 8 and the x minus 3 so we can kill the ones at the bottom?
All right. All right. Let me see. I think I see what you're trying to ask. All right. Now watch. All right, so let me rewrite what I got here because this is important. All right. Now, notice I had you distribute before you wrote it over the bottom. I have a reason for that. If you were to do this, which is completely right so far, this is completely right so far. I want to make sure you guys understand. No mistake has been made yet. I'm about to make a really big, crazy-ass mistake. And then I go, oh, sweet, duh. What mistake have I just made? Number one, shouldn't that should bother you? I desperately need this in order to do, I don't need it anymore. What the shit? If you needed it, why do you suddenly don't need it anymore? Right? Doesn't make any sense. But on another level, of course, why is that not allowed? Because division cannot cancel parts of an addition problem, right? That's something plus something. Division is not the opposite of addition. No cancellation can happen in this case.
So if it was multiplication in the middle, we'd be able to do it.
Totally. And it wouldn't have been. But yes, if it was, all day. Then it would be like 7-2, where I just kill everywhere I see something the same, because it's all multiplication. This is plus. This is a mistake. Don't do this, right? That's why I kind of try to have you guys distribute before you even write it down, so your brain doesn't even have a chance to go, oh, sweet. Yes?
I think I missed something at the beginning. Why why did you multiply or bring up x minus 8?
I didn't bring up anything. I love it. That didn't have an x minus 8. So then I multiply top and bottom by x minus 8.
Okay.
Yeah, it's the same thing I do if I had 1/9 plus 1/27. Wouldn't I multiply this by 3? I give it what it's missing on the top and bottom. Exact same thing. What was the bottom missing? X minus 8. So I have to do it to the top and bottom to make it legal. I like it. Same thing with equation. What do you do to an equation? Whatever I do to one side, I've got to do the other side to keep the balance. Don't I have two sides here? Top side, bottom side, or the upside down. So whatever I do to the top, I got to do the bottom. I like it. Let's try another one. And then I got a little handout. Yay. All right, let's try with a negative in the middle. So what if I had, what you got, Jeff? Oops. Yeah, that'll work. That's exciting, Jeff. All right. Ooh, I like it a lot. I like it so much. I love you guys. The first step is factor. Don't try to think ahead. Don't try to think of where this is going to go. How do you factor the first dude?
Take out the y.
Y. Y squared minus 4.
Am I done factoring?
No.
Nope. How do you factor y squared minus 4?
Y plus 2. Y minus
Good? Is that cool by itself? GCF saves your ass so often. The most common mistake is to try to force something that's not going to work because you forgot the GCF.
2. Oh, I see what
Always do GCF first. And then what about this guy, of course?
Take out the y squared.
Yeah, and then I'm done, right? Now, let's see if you guys, let me try to do the next step, which is give them what they're missing relative to the other one, right? You got chocolate sprinkles out in it, okay. You got rainbow sprinkles, okay.
The other one's missing a y plus
Oh,
2.
One more color, too bad for me. See if I can make it work for a second. What has he got on the bottom? He's got a y plus 2, and a y minus 2. So what's he missing that the other dude has?
Y.
He's missing a y. He's not missing a y squared.
Y.
He's got one y. He's got 2. He got 2 pieces of chicken. I only got 1. You're going to give 1 piece of chicken in this one, right? You're not going to give chicken. Here you go. Take a whole bucket. You might, depending on what else happened today. But times y. Come on, Blue. You're going to work. You're going to work, Blue. There. Now, what's this guy missing? That's not too hard. I mean, what's he missing?
Y plus
Y plus 2.
Y plus 2. That's all he's missing, right? He's got the 2 y's. He's got the y minus 2, so he's just missing y plus 2. Please don't make more of it than that. It really is just that. Factor both bottoms. Compare them. Give whoever's missing something what they're missing. It's almost too nice to believe. I know some of you out there are like, no, it isn't, Jeff. Too nice to believe would be you just
Give us the answer.
quitting your job and giving us all A's.
Sounds good.
Aw, I won't take that person. All right. Now, is everybody cool with that first step? Is that decent? You guys at least see the idea? Now, what do I have to be careful about?
The minus.
The minus. So I highly suggest you make the plus and negative. See that? So now I'm not going to forget it. What am I distributing now? a negative 3. The negative is going to be a part of that. I'm not going to forget it. Yes?
Wouldn't that make the y plus 2 y minus 2? They just out, or would you do that?
I only have one negative. I could put it on the 3, or if I really feel crazy, I could put it in here. I put it on the 3. I only had one negative. I only have one. Does that make sense?
Yeah.
All right. Yes? Yes, now I'm going to do that. I want to make sure everybody's got this step just by itself. It was minus, and I made it plus a negative so I don't forget that negative. That's one way you can do it. If you don't like that, figure out another way to not forget that negative. So what I get now, I get 4y,
Plus negative 3y
negative 3y, so minus 3y,
minus 6.
minus 6, all over y squared times y plus squared times y minus 2.
I'm confused because I thought last time, I mean, I know that this way you just plus the negative there, but I thought last time you literally distributed the negatives to each property.
Totally. Yes.
So,
Do you see how didn't both of these get a negative?
yeah, eventually.
But that's all that matters, is that they both get the negative. So now watch. If I would have left a minus here and put a 3 here, and then made it 3y plus 6, and then brought a negative through, wouldn't I have ended up at the same place? It doesn't matter if you bring the negative through immediately or if you bring it through later. You're bringing it through.
Okay, because we're multiplying.
So it's easier to stick it with the 3 and take both the 3 and the negative through. Just get it all done at once. You don't forget the negative's got to go everywhere then, because it's just going to go everywhere.
Okay.
Does that make that's why I suggest to do that. That's the easiest way to not forget it. Just put it on the thing you're going to have to do anyway, right? It's
But
like
if there
that's
was, like,
why.
no multiplication on that top part, you would just bring it in. You know what I mean?
Oh yeah, totally. Yeah. Then you have to,
Okay.
yeah, remember to bring it through. Yes.
And so for the denominator, how do you know which ones to take out when you figure out which ones they don't have?
I didn't take anything out. All I did
Or like
was right. That's what he was. So he's missing another y because the other guy's got 2.
So then you just
And then he's missing the y plus 2 because that's the other guy's got a y plus 2 and he don't. That's it. That's all that step is. What is it? Factor it. What is it? What is it missing the other dude's got? That's it. And I understand that on one level it's almost, you're like, it can't be it. Math is not supposed to be easy. And some other you guys are like, don't say the word easy. Yeah, I'm happy. Do you understand? I break it down, see what it's got. Is everybody cool with the fact that he's got 2 y's, so I need to give him another one. Top and bottom, make it legal. He's got 2 y's and a y minus 2 and a y plus 2. That's not fair. So I give him a y plus 2 also.
so the denominator becomes y squared, but like
What's
I
this?
can't really word how. That's why. Okay.
That's y squared.
So you're trying to make them equal, and once you make them equal,
Yeah.
then you put that equal one on the denominator.
Of course. I mean, how does this work? I made them both 27. So now I got 3 27s plus 1 27s. 3 plus 1. So I get 4 27s. I mean, I am not doing anything different than this problem right now. Those are the same problem. Why does that one look worse? Because some of its parts of its numbers are unknowns. Of course, it's going to look worse. But every step I'm doing is actually the same damn step I would do over here. Okay, I like it. And then, of course, the last step, or maybe the last step. What do I do now?
Combine more terms.
Yeah. So now you have y minus 6. So it doesn't look like anything is going to factor or cancel anything. Please, dear God, no reason to multiply that bottom back out. No reason at all. Leave it like that. All right. So here, let me give you this. Let me finally shut the hell up. I gotta, let's say what some of you guys are thinking. One side of this focuses on the idea just using numbers. So if you want to look at that side, it explains the idea like I did to begin with. And the other side is an example of what we just did, and then I want you guys to do these 4 problems at the bottom.